Okay.
That's your only thing that you have to do is not move.
You're gonna, once you get the chocolate chips, those are the ones you're gonna sell, so that you know you make a profit or a loss. So, do you want to look around, verify whether your chips are worth? I don't know.
So
Because for each chip, you're going to sell it at $2.
each chip
Two
is
whole
$2.
chip, two whole chip is gonna be $2, and it's gonna be $1 if you break it. So you need to mine it and make sure it's whole, not broken. And you're not supposed to touch the cookie with your hands, only with the tools.
Oh, Jesus Christ. Okay. I want a paper clip and those two, like this two.
Okay, 1 and 1, right?
Yeah, 1 and 1.
Okay.
So that's $10.
Yes.
Jesus Christ.
Yeah. There you go.
Oh my God.
Pick one.
I only have $3.
Yeah.
Stop it.
Pick one. Pick 1 and 1.
Stop it now when he's doing stuff.
Okay.
And then 100.
Yeah, we shall go with that one. The full one. No, it's not. Time.
Yeah, that's my last
Time.
one. Oh, wait, I'm making mine.
All right. Okay, so.
Yeah, this one's
All right.
Yes.
So, damn, it's a lot of counting squares.
Yeah, that's job on you. That's your
Just
fault.
split it up into one, bro.
Yeah. So, 1.
Hey, that's $1?
Yeah. No, it is $1. 1, 2.
Ian, you're
Three.
supposed to invest. You did the
I did invest.
4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21.
Actually, it's a smart idea to cut it.
23, 24, 25,
26.
20. so that's 20. So that's yeah. Okay, so that's $26.
Yes.
Okay, but
Don't look at the damage.
so 26
God, no.
total value of chips.
So let's go with just 40. So you owe us money.
Yeah, there's too many fucking squares to count. Sorry about that.
Let's
So
go with
reclamations costs. That's yeah, you're in the hole, man.
bankrupt, dude.
Let's say like 1.
One what?
One square.
No, you kidding me? Just here, just no.
No, look, all of this is a square, basically, technically.
Well, then if all of that's square, then
Okay, no.
technically you only get like.
So you have to pay for one big square.
Ian, either way, you're bankrupt.
Okay.
Like you're not making any money.
I
off
can run away to Mexico, nothing will happen. Actually, that's a bad idea, because I would get more rewards.
this. Yeah, I mean,
So 40.
yeah, just slap him in with 40. I was gonna ask you though, do you buy the regular cookie or the deluxe cookie?
No, he bought the $5 cookie.
Which one is? That's the more expensive one?
No.
Okay, good.
But like,
You're awesome.
no,
Okay.
but like,
So
Don't go
total
with the
cost.
other one because it's the same shit.
yeah, I know, yeah, they are the same.
So you're in the hole, man.
Yeah,
I mean, do we really need to do this to make you feel bad?
yes. Make a hole. Oh my God, yeah, there it is. Holy Jesus.
I mean, so you can move the sound more to see like bigger changes, but it'll adjust to what the changes that you need.
And the blue
body of water.
Yeah, the blue's body of water.
Oh, this is.
And the green?
This is
So
water?
the colors,
So, like, if I go
except for
like
the
that, it
blue,
connects
are the,
Blue is water and the rest is like.
lower?
it's telling you. No, it's just telling you elevation. So the reds and oranges are higher, and then going to green is the lowest.
So what happens if I like drill them?
There's not like a legend or anything, so you can't really. It's not self-explanatory. But the colors indicate elevation. Except for the blue, which is
Dude, I am like God right now. I can make like Mr. Navarro. Yeah, Mr. Navarro. So like if I go like I want what? Oh God, that's red.
Yep.
So the colors indicate elevation. The reds and oranges are higher, and then the greens that you see are lower.
And the closer the lines, it's steeper, right?
Yes.
So like if I go like that. Water spread. Oh yeah, look, it spreads. Dude, I feel like God right now. Jesus Christ, this is amazing. I want here. I want water. If I can't reach water, I will eventually reach water.
There, you made
So
something.
I guess what you're doing is kind of digging down to the ground water,
Yes.
so to the reservoir. So you could probably do that in real life.
Dude, I feel like God right now. Jesus Christ, wanna try it?
Yeah, I'll try.
Yeah, go for it.
Oh, we have another.
Yeah. I mean,
Oh.
if you guys want to use your hands too, it's all.
This is the dinosaurs, and there's actually no dinosaurs in here.
All right, ready? 3, 2, 1.
They didn't know that. Wait, it's that volcano now? We should build a volcano now.
Mount Vesuvius.
This is
That would be harder.
yeah, that wasn't it.
Well, now it turns red because you guys made it down more. It doesn't down.
We're trying to destroy it slowly. This is. Ooh.
Oh, you made a saddle.
You're right. It looks like a face.
Yeah, you made a saddle. Are you guys geology majors?
No, high school students.
Do you guys know about saddles?
With ice, and we're going to see how it actually applies, believe it or not, by understanding this kind of environment. We can see other environments that are not so close to Earth, but if we can understand a little bit more about the Earth, we can actually then apply everything that we learn here to somewhere out there. You get to see something like that, or similar properties on a little moon. This is like my favorite, most awesome moon in the entire universe. This guy is called Enceladus. Enceladus was discovered a couple hundred years ago, a little over 150 years ago, by a British astronomer, and they found this little guy orbiting this really, really huge guy called Saturn. And what they found out just recently, relatively recently, back in 2005, there was a satellite called Cassini that's no longer in use now. It actually plowed into the atmosphere of Saturn and actually burned up and everything. Yeah, that's the one. Yeah, that's the one that they actually took a lot of cool pictures like this. So what you get to see is, you get to see ice volcanoes on a little moon called Enceladus. What causes these wonderful ice volcanoes? Well, I'll tell you in just a sec. But in the meantime, take a look at these fantastic pictures. This is Cassini, the spacecraft that was actually traveling very, very close to the surface of the moon, and it actually picked up these geysers. Then these geysers are actually coming from, bless you, these are coming from these locations called tiger stripes. So what I'm going to do is I'm going to see if I can blow this image up a little bit more. And so what we get to see is the southern part of the actual moon, right here. You see these little lines, these little streaks? These are what they call tiger stripes. You get the idea of why they call them that. But this is the source of those ice volcanoes. So as the satellite was actually coming in over the surface, right above the top, they could actually see all of these ice particles that were coming out. And they found out that the composition of those ice particles was not just water, like your typical water you would get. They were made out of methane, you had some ammonias, you had some organic stuff that was coming out of this little moon. It doesn't necessarily mean that, come on in if you want. Doesn't mean necessarily that there's life on there, but there are ingredients there for life, and that's why a lot of people are kind of interested. And I bring you guys back down over here, back on Earth. And I was like, why does this connection here, over here in the Arctic or the Antarctic, how does it actually connect? Well, first of all, the similar processes, the geoprocesses, or the geophysics, the geochemistry of this landscape, if you will, here on Earth, helps us to understand landscapes that we haven't yet set foot on, but we can actually have an idea of how they would look like, at least, and see how they behave from a point of view from a satellite. And so the surface, see how white this is, see how bright that is? That reflective property is very unique to ice particles, or basically ice. And so when you take a look at stuff like this, you can see that there's a little bit of a similarity. Now, the reason why this is also kind of important that we understand our environment and how we can actually take care of our environment as well is because we get to basically practice and flex our science muscles in understanding what causes these ice volcanoes occur. So you have this is Saturn, the guy with the big rings. And what happens is as this guy gets closer and closer and closer to Saturn, guess what? It squishes it. Gravity, the gravity of Saturn is so big, because it's a big planet, it actually squeezes the poor little moon like a little stress ball. And so it basically squeezes water, squeeze, squeeze, squeeze. And all of this stuff right here is actually what's called tidal effects. The same kind of idea that you would see if you guys live near an ocean, like when you have high tide, low tide, that's due to the Earth and moon gravitational pull on each other, and the waters will rise and the waters will go down. But see, on Earth, the water is on the surface. On the moon, not the case. The water is underneath the surface. So the water, instead of being able to move freely, guess what? It's trapped. And that water gets to push up, and it pushes up very, very hard. That water pushes up hard up to the surface, and then when it pushes up, it creates little cracks. And once it makes cracks, it starts to make these little ice volcanoes, and then they spew out, and then those ice volcanoes then start to form, guess what? The outer ring of Saturn.
Whoa!
That's what they end up doing. So the outer ring of Saturn is actually brought to you by Enceladus. It's called the E ring. And so you get to see a little bit of gravity. You get to see how a lot of things are actually put together. And understanding here things of properties here on Earth help us understand stuff that's out there. Notice I just said everything was about how we learn here are things about like tidal effects on Earth and whatnot. Same effects over here.
So metamorphic rocks are heat and pressure, right?
Right.
You're about to see a
And you're going to demonstrate that by smashing it and squishing it.
a prime example of heat and pressure.
No, then pop them knuckles together. Does that look like?
My knuckles hurt now.
Now melt it.
But it's still the same composition. Or the chemical composition.
That's the heat and that's the pressure. I mean, that's the heat and pressure.
So look at his. You're bleeding out together, right? Oh, you're bleeding. Yeah, look at this.
I assault the rock. I don't love it.
It's pretty good. It's like a big old metamorphic
It's dangerous.
rock of pretzels and chips.
All right, let's see it. Let's see the final product.
It has
See,
it
like it
melted.
turned it melted for something. Mine looks like.
So it did melt a little.
He's got a good one.
This is metamorphic rock.
Hey, mister. Hey.
What's up?
You haven't got any regrets right now, go.
Wait, what?
You have to leave?
I don't.
No.
God damn it. Sorry, it's because. Why the hell is it that crap? Alright, so far, everybody has what they have, alright? So
Oh, Jesus Christ.
keep mixing, you.
Mix it up, mix it up, mix it up.
Get the, all of it, all of it.
Collect as much as possible.
Yeah, you're collecting pretty much all of it. Yeah, you're good there.
I'm getting there.
You're kidding me. You gotta do it faster.
There you go, buddy. Hell yeah.
Come to me, my child.
Ugh.
Sorting by density. You know what density is?
Yeah, no.
It's all heavy.
Volumes.
Okay.
Something dense has a lot of mass and a little bit of volume. Something that's not dense doesn't have a lot of mass, the same volume. So we measure this in minerals with specific gravity. I'm gonna give you guys a folder. So specific gravity, and it's measured against a cubic centimeter of water has one specific gravity measure. we're not looking for gold here, really. There might be some. There could be some. There's always gold. You never know where it is. You find it, and you find gold. Good job. But we did put pyrite.
Oh, nice.
So pyrite isn't a 9, but it's a 7.
Okay.
So that number difference is still pretty big. Going from 2 to 7 is still twice as heavy. So what we're going to do is we're going to use water to sort by density. Okay? We know water is 1. So we stick it under the water. And while it's under the water, you're going to start shaking. So you'll notice that these pans,
they're right size.
these pans have these lines on them. So these are riffles, and they're designed to work like little cracks in a stream bed, and those little cracks stop the bolt. So you just that's what those are for. So they help you catch things that might want to get out, but you don't want to. Going.
Oh, that's a cool piece of pyrite right there that he's got.
Whoa! I still have rocks.
Keep going with yours, man.
I still have like, I still have like a lot. Alright, so, okay.
So you gotta shake it. See how it flows?
Yeah.
Until it runs out of water.
Oh, there you go.
See guys like these are worthless. You can take those out. This guy might kick out gold. So you don't want those guys.
So this is good.
That's what we're looking for.
So, like,
Yeah. Ring sulfide.
He gets to keep the pyrite.
Circles. Circles, yeah. There you go.
Hey,
I'll see it.
He
wow.
got some pyrite. He's got a bunch of pyrite in his. Look at Look at Yeet.
Look at my niece down now. They went to the edible rocks.
There's still that. Did we go to that one?
That's gonna be in that room right over there.
Alright.
Go there. Some M&M, Oreo.
Oh, we did that one.
Hershey bar.
We did.
And,
That was good. That was a cool one.
Sugar wafer.
Okay, I got all of this rock.
Oh wow, look at all. He's got a bunch of pyrite. Look, wait.
Wow. Professional gold.
You're at the point where you can get the stuff out.
I'm gonna be rich.
With your hot Eddie.
Oh my god, there's a lot of
Oh.
They just launched a weather balloon.